लिंक भेजना।
Hello, hello, can you hear me? Please respond. Yes or no? Hello.
Yes, sir, you are audible.
Okay, okay, thank you. So let's start today meeting. This is last assignment. So first question, the first three peak in the XRD pattern of FCC face-centered cubic structure material are option A, B, C, D. Please choose the correct option.
Sir, D.
Okay. How? Why is D is correct?
Sir, for FCC, the H square, K square, and L square sum comes around in the form of 3, 4, 8 pattern.
3, 4, 8. Okay. Another? One
And
more.
another one will be
No, no. Option B
11.
is correct. But another method is also there. You have you are saying like that. Okay. So D is correct. Let's say. Let's see what is another thing. You can see FCC. Sir has already discussed in class. HKL must be for FCC. Unmixed means all if all are even or all are odd. You can see this is all are even odd and this is all are even. In other options this is not possible and this is not possible and the all are even all are odd. Why not? Hello, what is square sum? 4 and 9. So 3 square 1 square 1 square 11 and this 4 4 0 8. C option, why not C is correct? 4 8 11. So first three peak, please see. Okay. So lowest value, go with lowest. So this is unmixed, but this is next fourth peak maybe 11. Okay. Hello. Clear? Anmol?
Yes, sir.
Okay. So please read careful the question first three peak. And this is simplest way. HKL must be unmixed means all are even if all are odd. And do you know where this is strand come? Because this is formula how we can generate. So there is a structure factor HKL equal to summation over 1 to n fi to the power 2 pi iota h. If this is 0, then diffraction is not there. If this is something else other than 0, some value, then diffraction will be happen. Okay, so when we apply the condition with position UVL, UVW, this is the position of the atoms in the lattice, and we put this number, then we can calculate for simple cubic HKLR. All HKLR are permitted. Okay, so please remember this thing, and also the how we can calculate the structure factors and these condition, how can calculate. Let's go with another question. Following is are not true. Correct statement about X-ray diffraction from crystals. Option A. Intensity of the peak is proportional to the half of the square of the structure factor. Structure factor depend on the unit cell shape and size. Structure factor depend on the position of the atom in the unit cell. Structure factor is independent of the element in the crystal. Please choose the correct option. Yes, please. About X-ray diffraction. Not correct. Intensity of the peak is proportional to the half of the square of the structure factor. So option A and B is not correct. The structure factor depend on the unit cell shape and size. So you can see structure factor dependent HKL and position UVW. This is related to the atoms like CSCl. So this 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 will be different for CSCl. If the material are same like the Fe only, so option A, intensity of the peak is proportional to the half of the square of the structure factor. Intensity you can see square proportional to the direct square, not half. Okay, so this is not correct. So not correct statement. So option first is according to question is correct. Structure factor depend on the unit cell shape and size. Shape and size. Position is dependent. Okay, we can see element dependence, independent of the element of the crystals. Structure factor is independent. Hello. So please remember this formula. This is the structure factor and it is dependence square root square of the amplitude, and we can define as f equal to amplitude of the wave scattering by all the atoms in the unit cell divided by amplitude of the wave scattering by an electron. This is the definition of a structure factor. Okay, let's move to the third question. In powder diffraction experiment using copper K alpha, radiation of wavelength 0.154 nanometer in the first 5 peaks observed from the monoatomic cubic crystal. When the angle to theta are given, this is this degree. What is the crystal structure of the material? Like FCC, BCC, diamond cubic, or simple cubic. How can we calculate? We have discussed in last class. Sine square like that term. First calculate sine, then sine square, then divide by sine minimum with sine square and simplify in the integers, and h square k square l square, find simplest number will be h square k square l square, and we can say from h k l square simple cubic FCC or body center or diamond cubic. So can you calculate? You have a 5 minute. Please calculate and show me what is the answer. So you have remember we have discussed this type example in last class. Please calculate. You have a 5 minute. Please calculate. Please calculate. I am waiting. Are you able to? Hello, one more.
Calculating.
Okay, I am waiting. Okay, thank you.
So I think it is FCC.
Okay, FCC. Okay, so let me calculate. And I have already done calculation. So around it will be 2.675 and 4.015. So multiply this number with 3. Let's say sin square theta theta. So it will around 3, around 4, around 8, 11, around 12. So h square k it will equal to 1.1, 2, 2, 2, 2, 2, 2. Okay, so you can see this is all are even, all are odd. First is even, second is sorry, first is odd, second is even, even, odd, even. So all are unmixed. This is also 3, 4, 8, 11, 12 FCC, or this you can calculate here HKL also. So this is concentrated TB. Okay, okay, now did you get it?
Yes, sir.
Okay, let's move next. Which of the following Each of the following characteristic of the material can be accurately determined by using X-ray diffraction technique. Vacancy, concentration in the material, identification of the phase in the material, determination of the strain in the crystal atom size measurement accurately by XRD. Please choose the correct option.
Phase determination, strain determination is there.
Accurately, Okay, so answer is phase and strain, and these are the application of XRD: phase identification and strain and crystal size. Advanced version, we can calculate crystal quality and texture atomic position also. Which of the following is the diffraction condition for the diffraction from BCC lattice? What is interview? HKR must be mixed, unmixed, or H plus K plus L must be even or odd. So please choose correct option. C. No.
But it will be CH plus K plus L must be even.
Okay, so let's see how this is happen. Okay, so body centered cubic, one atom, let's say in body, other are corners. This is body center BCC lattice, unit cell, sorry. Okay, and let's say this is origin, at origin, and What if this is 0 0, then it will be half half half. Yes. So do know structure factor bodies and BCC. Let's say monoatomic. So I equal to 2 and so let's say choose one. Okay. And into the power I 2 pi h scale and position. This is UVW. So when we multiply 0 and half of 2 pi to 0, so it will if we take common, this is okay. Then if let's say h plus k plus l equal to odd, what happened? Let's say 1 e to the power will be minus 1. So f will be 0. Yes. So there is no diffraction. If h plus k plus l equal to even, then let's say 2, then 1 plus e to the power 2 pi I with multiply f till f. Yes. So this is some number. So diffraction will be there. So must be even. Okay. Understand? Did you understand?
Yes, sir.
Okay. So like this we can calculate for any given system if you know the structure and position. This is previous. Okay. The next question, in powder diffraction experiment, cobalt alpha radiation wavelength 0.179 nanometer. What is the diffraction angle for the first order 220 set of plane from the BCC structure iron with lattice parameter? This is 0.2866 nanometer. So please calculate theta. You have a 5 minutes. Please do it. Hello. Yes, please answer.
Sir, A1 to 4.
One, two. Okay. So let's distance. Do you know 2D sin theta equal to n lambda diffraction angle? So we have to calculate 2 theta. Let's and BCC structure for BCC equal to h square k L square. A is given, lambda is given, n equal to 1, n equal to 1, lambda equal to 0.7 meter, and HK is given to 2. We have to find 2 theta. What is 2866 diffraction angle. So let's put this value d h square k square l square sin theta equal to 1 equal to 1.7 meter. So sin theta 7 with h square square 2 square plus 2 square plus 0 square divided by 2. It is a 6 in consider what is 0.8832. Theta will be 62.03. So 2 theta equal to 124 around. Okay. Which of the following are the zero dimension defects? Grand boundary, so defect, interstitial, atom, dislocation. Please choose the correct option.
Scott K and interstitial.
Yes. So zero dimension or zero defect, point defect, missing atom or vacancy, interstitial atoms, substitutional atoms, Frankel or Schottky defects. This will be in ionic solids. Which of the following are referred to as equilibrium thermodynamic defects? Equilibrium thermodynamic defects. Dislocation, grand boundary, vacancy, joint boundaries.
Vacancies.
So vacancies, equilibrium defects will be in zero dimension, a point, and we know the zero dimension. In zero dimension, vacancy is there. Okay. Next, sort key defects is option A, pair of anion vacancy and anion interstitial, pair of cation vacancy and anion interstitial, pair of anion and cation interstitial, Pair of anion and cation vacancies. Please choose the
Pair of cation and anion vacancy.
yeah. What?
So option B.
Okay, so it will be opponent pair of anion cation vacancies. You can see pair of defects in ionic solids, Frankel or Schottky. So Schottky. The theoretical ratio of the so yes, the theoretical ratio of the intensities of the first two peak in the XRD pattern of the BCC structure material is please calculate
So 1 by 2.
how
So BCC has all even 2, 4, 6, 8 patterns. So 2 by 4, 1 by 2.
what is first and second peak HKL
2
index
and the h square plus k square plus l square value is coming 2 and 4.
H square KL is L square equal to first what is value HKL first peak at
So
second
2.
pattern. I am asking HKL independently. This is intensity for BCC 1.0 20. Second will be 200. So first is 2 for first HKL 200. Sorry, 4. And this is also related to the by 4 of are you saying like that? Yes.
Yes, sir.
Okay. We can also calculate from D 200 also related to the intensity ratio, peak intensity ratio. So let's calculate. This is second method. BCC 20 centimeter cubic. It will be around 1 by 2 and divided by 1 by root 2. Yes, this is root 2 by 2 square. Okay, how we can calculate D200? Sorry, 2 A by 2 square by 2. Similarly, yes. So we can also calculate. This is related to the structure factor, and we can easily calculate with the help of D intensity ratio. Okay, Let's move further. Half. Which of the following is are true for the edge dislocation? Motion of the edge dislocation is perpendicular to the Gaussian vector. Dislocation line is perpendicular to the Gaussian vector. Motion of the edge dislocation is parallel to the Gaussian vector. Dislocation line is parallel to the Gaussian vector. Please choose the correct option. You have a 5 minutes. Please find the answer. Yes, please answer.
So dislocation line is perpendicular to the Burgers vector and the parallel to the Burgers vector. Motion of edge dislocation B and C.
Okay, so this is correct answer. We can see dislocation is perpendicular to the budget vector. Dislocation, it is perpendicular to the B. You can see, and motion of the edge dislocation. Here we can see. Yeah.
Sorry, in this case, if it would have been screw dislocation, would C will be the correct answer, and instead of perpendicular, it will be parallel to the Burgers vector dislocation line.
Yeah, yeah, you can see this. This is okay, parallel to the budget vector screw dislocation. Okay, in screw dislocation, B is perpendicular to the budget vector. Yes,
So parallel.
Oh, sorry, parallel. This is perpendicular. This is parallel. Next, the purchase vector of the dislocation in the case of PCC lattice. Please choose the correct option.
And B.
Option B. Option B is correct. Please remember these things. For FCC 100 plane with the half of the lattice parameter equal to the purchase vector, we can calculate amplitude of the purchase vector and PCC, and we can calculate the energy related to the thermal modulus and purchase vector with the help of. Next question. If the element having FCC crystal structure has lattice parameter of 3.57 angstrom, what is the magnitude of the purchase vector in angstrom for FCC? Lattice parameter have. Please calculate.
So 2.52.
Okay, yes. For FCC, we can see P equal to A by root 2, and A is also given here 3.57 angstrom divided by root 2. When we calculate, it will be around 5 to angstrom magnitude. Okay, next, Cooper's shell modulus and lattice parameter are 30 gigapascal and 3.65 angstrom respectively. What is the elastic strain energy per unit length that is location line in the copper? Please calculate. You have a 5 minute. Please calculate. Yes or no? What is the answer? Arjun 14. Okay.
9.9, I think.
Yes. So option B is correct. How we can calculate this?
So if using the formula of strain energy half GB square.
So equal to half GB square. How we can calculate GB? This is
It can be
copper,
calculated from the formula of
cop, copper FCC. So it equal to a by root 2. Yes, and a is 3.65 2. This is also given yes, I so after b square six minus 20 calculate values. Okay, last is the structure factor of the ordered CSCl will be. Please calculate this. I have discussed and we can calculate equal to 1 to m fi to pi hkl. This is the formula, and there is we can calculate like that. Let's say there are two CSL. Let's first assign CS. Second will be for CF. This is the end. Please calculate now. You have 5 minutes for this question. Please calculate. Hello, yes, please. Are you there? See how? Please show me the calculation you can send in chat. And more, let me give you, let's say, CSCL structure. Please find the CSCL structure first. There will be chlorine, Cl, and you can assume half of, sorry, so this CS Cl position for Cl position and CS you can assume 0, 0, 0. Please put this number, then solve. Arjun Cl 4Cl half, you can assume, and CS 0, 0, 0. One more, now are you able to? If the position is this,
Yes, sir. We will put the value, and I think then it will come C.
so please calculate. I'm getting. So this is it's from, so assume two case. Say first H plus K plus L equal to E1. After putting let's say 2 CS plus CL. Second or so to put this value minus. Okay, so CSCl for E1 plus and CSCl for what? Clear? Yes. So today we have
Sir,
discussed. Yes.
sir, I have sent you a mail
Yes.
uh, where previous assignment questions are there. So can
Yes.
we look into two or three of them? I have doubts related to that.
Okay. It will have sent me mail. Which email ID? Okay. So, question assignment 6. Which question?
So can you move down a bit?
Yes.
Sir, sir, here in question number 6.
6. Okay. So what is the doubt?
Sir, according to the live recorded lectures,
Yes.
SiO2 three-dimensional SiO2 structure is correct for quartz, but here the only answer is clay, and there was no structure given for clay itself. So, in this question, how will we get this answer?
Okay, so this is your query. Okay. Let me discuss with your this TA. So after discussing with your TA, assignment TA, I will send you email with correct answer. This is fine. So let me
Yes, sir. Sir,
let down the your query. Question 6 and assignment 6. Which question? 6. Answer according to you, according to the lecture, answer will be A. Yes.
yes, sir.
Okay.
B, there was no structure for clay also mentioned in the lectures.
B option not mentioned. Mm, Lecture, lecture. 7th, 8th, 9th, 10th, 11th, 12th, 13, 14. This is correct.
Yes, sir. And from assignment 7.
Uh, maybe some error there because when we TA upload the answer of the like data, some mishappening will be there. So after discussing, we will send you email. I will send you email. Okay. So which question?
So can you move down a bit? Sir, question number 4.
X-ray can be penetrate into the metals because of which of the following characteristic? X-ray. So high energy, longer wavelength, shorter wavelength, low energy.
So
What is
here
the
I believe that the high energy and short wavelength both will be the correct answer.
high energy is also there? Okay, but how much comparison is not there. So what is the range of the X-ray? Let me calculate energy of the X-ray. How can we say this is low, this is high energy? What is the criteria? X-ray can be penetrated to metal because of the, okay, with the reference of metal. So let me tell you what is the range of X-ray from where to where. Wavelength. Shorter wavelength.
Here I meant to say that if the wavelength is getting shorter, it is
Yes.
synonymous to get
Yeah, yeah.
energy increasing also. So it has high
E
energy also.
equal to hc by lambda. Lambda is lesser than energy will be higher. And what will be the order of the energy? What is the lambda for metal that can be penetrated? Please find the. Can you search in Google?
Listen, let me.
So 7 question. Arjun 0.122. This is energy. Lambda for X-ray 10 to 0.2 nanometer to 10. 0 to 10. So energy will be for test wavelength 120 kilo electron volt. Hello Anmol.
Yes, sir.
So wavelength for test around 0.02 Arjun tell me, and 10 nanometer. This is the range, and energy will be 120 maximum for test wavelength kilo electron volt. It will be a higher energy, but when we compare with, let's say, gamma rays, so when we compare with gamma, it will be lesser. For kilo electron is also higher energy. Let me discuss this. Otherwise, put the numbers. This is not lower energy, of course. 120 kilo electron volt is higher energy. Okay, your query. I will be sent you mail after discussing with TA. Assignment TA. What happened in these questions? Okay, any other doubt?
Sir, below.
Okay,
Sir, here in question number 7, you can see both options are the same, B and D.
PMT. Oh, so this is the again mistake. Generally, so correction window will be there, I think, and after the correction, let me question number C, PMT, same action. So this is again mistake when we upload the TA. Okay,
One more question also, sir. Down.
which question?
I think 13, sir. Can you go down?
Okay, 13. Yes. What
You
is
can
the
see, sir, like B and C are same only, sir. And another thing is like both are not higher. No, K beta is supposed to be lower wavelength.
K beta is on the higher wavelength side and Kelpa is the higher Kelpa is on the higher wavelength side.
Okay, there is no difference between option B and C. Both are mentioning
Kelpa
same.
is on the higher wavelength side and K beta is on the order is changed, but language is same and option is same. So this is again, I think, during the upload, B and C option are same. Okay, I think Sony is your tier. This
Sir, in the same question, why sir option D will not be also correct answer?
which question?
In the same 13 number question.
These are due to the diffraction from the X-ray. What it is? What is are true for two sharp peaks in the given? What is the true for two sharp peaks in the given plot? Where is the plot?
Plot is the K alpha and K beta plot. The
Okay.
basic one which is called.
So these are due to the diffraction from the X-ray. This is the characteristics of the, I think, Alpha K beta only will be there if the characteristics X-ray are generated. So these are due to the diffraction from the X-ray. Sharp peaks in the given plot.
So here in no angle is involved. No diffraction supposed to be angle measurement. I think this is more of absorption studies, maybe, or sweep studies, because different wavelength and different energy level it is studied. This graph, if you see above,
Yes.
so like each of the curve corresponding to, I think, different energy or different voltage, kilovolt, and that level.
Mm-hmm.
It's not, I think, diffraction study.
Yes. When we apply the higher voltage, then characteristics wave will be there in lower continuous only. So alpha beta, what is the alpha beta? Due to the diffraction from the node. So this is not will be the true. Yes.
Sir, but without the X-ray diffraction, we will not be able to get those peaks, na?
Yeah.
That's what I want to ask.
So that is like intensity versus angle. No? That graph. This is intensity versus wavelength.
Wavelength. Yeah. So 2 theta versus if we plot 2 theta XRD intensity. Beta. These are due to the diffraction from the X-ray. We have to find the origin of the alpha beta. What is the origin? How can we think? Let's say when we L1, L2, L3 alpha beta. These are due to the diffraction from the X-ray. Sorry, let me think more with proper. I will send you a map proper with clarification after. Okay.
Sir, one more thing also, sir. This
Yes.
previous live session slides, you have shared the link, no, sir?
What?
The previous live session slides. So I'm unable to download it. Whether other people able to download it, because it is coming as a slideshow only. Like we are able to see online, we are not able to save and then see in a PC.
1 minute.
It is available in YouTube. Exam.
YouTube is only video. 1 minute. Last time in the Google Sheet, the, this time is merging in singers link. Last time is different links for different slides. It will be easy for this time is okay. So let me give you to your link in chat box. Assignments 7. Yes, dear. Assignment 7. Do you want to the assignment 7 link? Hello.
No, sir. Actually, what we see, there are 7 links for the YouTube video,
Hmm.
and for the presentation, there was only one link. And when we click that, it is going to a page where we are able to see some slides, and like we are not able to like scroll through also in a proper sequence. So it is changing randomly to some slides. I don't know what about others' experience. Whether anyone tried? Anmol, have you tried?
No, I'm not proud. Actually.
So 1 minute, please. Let me give one separate
Okay.
one by one link in chat box right now.
Okay, sir. We'll take from
1 minute.
that.
One
Thank you.
minute. 1 minute. For today, you can see only. Okay.
So it's only for viewing, not.
Yeah. So let me modify. Please don't modify anything. Let me share with download. You can download also, but don't modify.
Okay, sir.
This is for 8 assignment. Okay. Did you find?
Yes, sir. Certainly.
Okay. Now next will this is for 7 at 7. Are you able to find at 7?
Yes, sir. Yes, sir. 7 also.
6. This is for 6. Five. This is for 5. Please find if there any error, please let me know right now. This is for 4. All are working?
Yes, sir.
Okay. 4. Please give me 1 2. This is for 3. 2.
Sir, 4, what you have said, I think it is solar photovoltaics.
Oh, sorry. Okay. Previous year. Okay. So we have to cancel. Please check if any discrepancy. Please let me know. Please check second. 4.
I'll check, sir. Yes.
Okay. So we have to. Okay. 4. Yeah. 4th. I have wrong. Thank you. Any other?
2 is okay, sir. I'll just see.
3 is
3 also is okay.
so 4th. Now check 4th again, please.
Okay, sir.
Okay, so first is minimum. This is for first. Please find all first, second, third, fourth, fifth, sixth, seven, eight. All are working and
Yes, sir.
so okay. Any other problem? Anyone? I think your exam will be in 24.
Yes, sir. Coming Sunday.
So this is last class, I think. You can send me mail if you have any query.
Sure.
Okay. So thank you, Olar. Very, very thank you.
Can you just wait 1 minute?
Yeah, yeah.
Sir, the exam will be for 100 marks, no?
I don't know what
Okay.
is the exam rule and anything else. I am only assigned for you live session.
Okay. Okay.
Any let me know what is the your query. Let me ask with your TA.
Can you check the question number 9 in this same assignment?
Seventh assignment.
In this assignment, question number 9.
Which assignment?
Try this one, this one.
Okay, question number
9.
so, question number 9.
Yes, sir.
Yeah, the wavelength of the radiation that could be used for diffraction to happen from a plane with atom metal can be computed as maximum interplane spacing of 3 angstrom. So, what is your query?
My query is that here 3 angstrom can also be another possible answer.
So, what is maximum interplanar spacing? D.
Yes, sir. The D is fixed here. Uh,
Mhm,
it is given that maximum interplanar spacing D is 3 angstrom,
mhm,
but the lambda and theta can still be variable. And on the basis of Bragg's law,
mhm.
the lambda can be less than or equal to the formula, since
Could
sine theta can vary between 0 to 1.
0 to 1. Okay. So, lambda also can be vary. So, the wavelength of radiation that could be used for diffraction to happen from a plane to determine material can be computed as the maximum would be. Let's choose two planes and diffraction from first plane and 4 seconds when we interfere. So think like that. One minute. So let's. These are two planes. This is interfere like that here. Constructive or de- de- destructive. And so, what is the question now? Is read 7 question number 9. The wavelength of the radiation that could be used for diffraction to happen from a plane where determined material can be computed as the maximum into 3 angstrom. So this is 3 angstrom. So we have to find possible lambda. Yes. Hello. Hello. alone mode.
So,
So for let's say this should be here the part difference is same, and again here the part difference is same after this. Okay, so that could be the minimum, should be the this additional, and what is it, d sin theta, I think 2d sin theta we have also tried 2d sin theta. So minimum, what is the minimum criteria for lambda here? Let's suppose find the minimum value of this equation. How we can find? N should be 1, minimum 2d sin theta equal to lambda, and d is 3 angstrom, and sin theta. What is the possible minimum value for this? Let's say should not be 0, otherwise non lambda.
30.
30, okay. So this will be half. So 3 also is there. Yeah, you are correct. We can say yes. So should be A option should also be. Okay, so question number 9. Anything else? Question number 9. A option should be correct also. Yes, and more.
So this much from these assignments.
So, okay, so thank you all of you, and best of luck for exam also.
Thank you.
Okay.
Thank you so much.